Now that we've seen what exactly L'Hopital's rule tells us, let's put this rule into action. All right, so we're going to solve some limits that originally produced the indeterminate form. Okay, so for example, number 20, right here we have the limit as x approaches 1 of the natural log of x all over x minus 1. If we plug 1 into both the numerator and the denominator, we have the natural log of 1 over 1 minus 1. The natural log of 1 is 0, and 1 minus 1 is obviously 0, so we get 0 over 0, that's our indeterminate form. So what do? We derive the numerator, we derive the denominator, and then we plug 1 in again. So we're still going to have the limit as x approaches 1. Okay. What's the derivative of the natural log of x? It's one of our rules from a long time ago. It's 1 over x. All right, so we have 1 over x. Then the derivative of x minus 1, well, x derives to 1, negative minus 1 derives to 0, so we just have 1 in our denominator. Now when we plug 1 into this, because we're doing the limit again, we have ourselves an answer. All right, so we end up with 1 over 1 divided by 1, which obviously simplifies to 1. That's it. That's how L'Hopital's works. A lot easier than trying to figure this out in some other manner. Okay. Example 21, we have the limit as x approaches negative 1 of the quantity x to the 6 minus 1 over x to the 4th minus 1. Again, we're going to plug negative 1 in first. And when we do so, we have negative 1 to the 6th, which is 1, minus 1 over, again, 1 minus 1. Negative 1 to the 4th happens to be 1 as well. We get 0 over 0. Okay. L'Hopital's will help us again to find this limit. All right, so what do? We derive the numerator. All right, so limit as x approaches negative 1. What does our numerator derive to? Yeah, 6x to the 5th. Good. All right, how about our denominator? It's going to be 4x cubed. You got it. Okay, now what happens when we plug negative 1 in here? Okay. Well, we have negative 1 to the 5th. That's negative 1 times 6. And then we have negative 1 cubed. And the denominator must be multiplied by 4. So we can see there that the negative 1's in essence there. We have negative 6 over negative 4, which is a fine answer, as is 3/2. Or 6 over 4, 1.5, whatever works for you. Finally, we have one that's a little more challenging. Example number 22. We see here that y is a function of x, function g of x. Y is equal to g of x. G of 0 is equal to negative 2. And the derivative of y is y times cosine of x. We're asked to find the limit as x approaches 0 of this expression. Well, 7 is itself e to the 0, well, e to the 0 is 1, plus 4 times g of x. G of, we're interested at 0, so g of 0 is negative 2. So we have 4 times negative 2 there, plus 1. In the denominator, we have 0 minus 0. That's definitely 0. 7 plus negative 8 is negative 1. Plus 1 is 0, so we get 0 up top as well. This is 0 over 0. L'Hopital's rule goes into effect. Okay, so this means we have the limit as x approaches 0 still. In the numerator, we have to take the derivative of 7e to the x. 7 is a coefficient, so it stays. And e to the x derives to itself. So we still have 7e to the x. Plus 4, right? G of x is going to derive to g prime of x. Right, so we'll have g prime of x there. And then the 1 derives to 0. So that's just our numerator. 7e to the x plus 4 times g prime. In the denominator, much easier derivative to work with, 2x minus 6. Okay, so now we get to plug 0 in again. When we plug in 0 a second time, okay, we have 7 times e to the 0, which we again know is 1. And now we have 4 times g prime of 0. That seems a little weird because we weren't given g prime, we were just given g of 0. Okay. In the denominator, we have 2 times 0 minus 6. Again, not so bad. So what do we do with this whole g prime of 0 thing? Well, we know that y is g of x. So if this is the derivative of y, it's also the derivative of g. We want the derivative of g when x is 0. So we can plug in 0 for x here. But we also have to plug in for y. We need the y value when x is 0. We were told that because, again, y is g of x. And when we plug 0 into g, the result is -2. That's our y value. So we have -2 times the cosine of 0. What's the cosine of 0? Yeah, it's 1. So -2 times 1 means that the derivative, g prime of 0, is -2. So we have here 7, that's 7 times 1, and then this we know is -2, so 7 minus 8 over 0 minus 6, which means we have 1 over 6 as our limit.